Module 5, Lesson 4, the area of all triangles using height and base. This lesson has been modified because we're doing this as a distance learning lesson. So I have changed it a little bit, but hopefully it'll cover all the basics. Okay, taking a look at the I can statements, I can construct the altitude for three different situations. An altitude that is a side of a right triangle, that should say triangle, I need to fix that, an altitude that lies over the base of the triangle, and an altitude that is outside the triangle. And I want to be able to decompose these three different types of triangles and show and explain that the area of a triangle is exactly 1/2 the area of a parallelogram. So the first thing we need to do is take a look at three different triangles here, and we need to find the altitude of each of these triangles. And these triangles represent the three different I can statements. One of them is a right triangle, one of them is an acute triangle, and one of them is an obtuse triangle. So starting with the easy one, on the right triangle I have the base here, and I have the altitude here. And remembering from other lessons that altitudes form right angles with the base. Taking a look at the acute triangle over here on the left-hand side, I have the base, and I usually just start with whichever side is on the bottom, unless it's obviously not the side on the bottom like it was over here on this right triangle. And I start at the point that is opposite the base, and I am going to come straight down so that I form an intersection with the base, and that intersection needs to be a right angle. Taking a look at the obtuse triangle, once again identifying the base. Now what's really tricky on this one is the point opposite the base isn't over the top of the base, it's actually out here to the right hand side of the base. So I am going to extend the base so that I can start at that opposite point and come straight down and form my right angle. So I have now on all three types of triangles identified the altitude, and as far as labeling, you could write next to it altitude, but I want to keep this video moving, so I'm not going to do that. So in the last few lessons, we have demonstrated that the area formula for a triangle is 1/2 multiplied by the base and multiplied by the height. And today we're going to show that the formula works for all three of these types of triangles. And this first question is, what is different about each of these triangles? And go ahead and pause the video for a moment, look at them and ask yourselves what is different, and when you're ready, resume the video. So as I look at these three triangles, and I've already pointed this out, the difference is where is this opposite point of the base compared to the base. In this acute triangle, it's over the base. On this right triangle, it intersects with the end of the base. With this obtuse triangle, it's way outside of the base, and I actually have to extend it so that I can see the base. Another way of looking at this is the type of triangles. This first triangle is an acute triangle. The second triangle is a right triangle. This third triangle is an obtuse triangle. So I can look at them and hopefully we see a connection between where this opposite point is and the type of the triangle. On acute triangles, this point is going to be over the top of the base. On these right triangles, this point is going to be right along with the base. And on these obtuse triangles, this point is going to be hanging out in space someplace, so we have to extend the base. I know I've said the same thing 3 different times. Hopefully you are hearing what I'm saying. So if we wanted to calculate the area of these triangles, what formula do you think we'd use? So this is where you'd pause the video. You'd probably actually want to try and write this out, give an explanation of why we would use that formula. And when you're ready, resume the video. Now if it were me, I would hopefully have paid attention to what's written right up here, and we'd have 1/2 multiplied by the base and multiplied by the height. In our class, we've had a little bit of discussion about why multiplying the base times the height and dividing by 2 is perhaps less strategic or less useful than using the multiplication. With the multiplication, we can use the commutative property, and we can rearrange the order of the factors. So maybe I can find half of the base and then multiply by the height, or maybe I can find half of the height and then multiply by the base. When we use this division formula, we are locked in by the order of operations to saying that we are going to do the base times the height and then divide by 2. So there is a reason for keeping it as the multiplication. Okay, so there is an exploratory challenge, and at this point you would want to pause the video and you will want to print out the polygons. We will have linked to them in the assignment, and I'll also add the link to the description of this video. But print out these polygons, and then what you want to do is cut out each set of polygons. And in each set of polygons you're going to find a rectangle, and you're going to find a triangle that goes with it. Your job is to cut up this triangle in some way to show that it is half of this rectangle. So cut it apart, move the pieces around so that you can show that this triangle right here is half of this rectangle. And that's step number 3. Prove that each triangle is half of each rectangle by cutting apart so it fills half of the rectangle. So this would be a good time to pause the video, spend some time on the activity. If you're working on this at home, maybe have brothers and sisters, mom and dad try it out with you. I know that runs into multiple copies, but go ahead and do it. Print out some pages and give it a try. When you're ready, go ahead and resume the video, and on the next 3 slides I have the solutions that I came up with to each of these sets. So here was my solution for rectangle X and triangle X, and you can see, and I did this on all of them, I found half of my rectangle, and then I took my triangle and I set it over the top, and I cut off this top portion here, and I cut it apart to fill in the side portions. And that was my strategy for all 3 of these situations, was to find half the rectangle, lay the triangle over the top, and then cut it apart. Now I know that there are other strategies, and I'm just sharing one that I did. So there was my solution for polygon X, and here is my solution for polygon Y, and you can see I did the same strategy. I cut it in half, I laid my triangle down and cut it apart. So I cut off this top section here and I moved it around to complete my half. And then for triangle Z, this one was a little more tricky, but I followed the same steps. I lined up my triangle, I cut off the top portion, I cut off this side here, and then I used these 2 pieces to complete my other half. Now on these, if you have some cool way that you did them, go ahead and take a picture of them and turn them in with your assignment. Turn them in with the assignment, and we can take a look at all the cool ways that students came up with to solve this problem. Okay, exercise 4, and this would be in your math workbook if you happen to have it, which most of you probably don't. So when finding the area of a triangle, does it matter where the altitude is located? Does it matter? Well, let's think about that for a second. It doesn't matter where the altitude is located. To find the area of a triangle, the formula is always the area is 1/2 the base times the height. So it doesn't matter if the altitude is inside the triangle. It doesn't matter if the altitude is the edge of a triangle. It doesn't matter if the altitude is outside the triangle. What matters is that it goes from one of the vertices, one of the points, that is a corner of the triangle, and it comes straight down and intersects with the base. That's what matters. And exercise number 5, how can you determine which part of the triangle is the base and which is the height? Well, pause for a moment, think about that. Ask yourself, how would I figure that out? The base and the height of any triangle form a right angle because the altitude is always perpendicular to the base. So I told you that I kind of start with whatever's on the bottom here, but you'll notice on this one I started with here. On this one I started with here. It would be just as easy, come back here. It would be just as easy for me to choose this as my base and come down this direction, and now I have a base and a height. What matters is that I have picked one side and I'm coming up with a perpendicular line passing through one of the vertices. So over here we could do the same thing. We could make this a base and we could have an altitude that goes this direction. What matters is they form that right angle. Alright, so closing. Why does the area formula for a triangle work for every triangle? Well, every type of triangle fits inside exactly half of a rectangle. It has the same base and height lengths. So these rectangles that we're looking at, they have the same base and same height as our triangles when we decompose them and take them apart and all that kind of stuff. Must be time for students to get here. Okay, so taking a look at the I can statements, so hopefully now you can find an altitude that is the side of a right triangle. Hopefully you can find an altitude that lies over the base, and that would be in an acute triangle. And hopefully you can find an altitude that is outside the triangle, which would be an obtuse triangle. And hopefully you had some fun trying to decompose these triangles and figure out what is going on. So that concludes Module 4, Lesson 5. And you'll want to look at the online materials for exercises, problem set, and exit ticket. And if you've got questions, reach out to your teacher.